Good morning, guys. Today we're going to be covering 8.11 equations of circles with centers not at the origin. So to get started, first off, the equation of a circle with center hk and radius r will always be written in the form x minus h squared plus y minus k squared equals r squared. And again, the point h comma k, that's just the center of our circle. Now, something that you need to pay attention to when you're doing these, since the center is at hk, and we see that we have negative signs in our equation, we need to be careful of those negative signs, those subtraction signs. Those will throw you off. So for instance, if I have the point 6, negative 3, when I plug into our equation, I'd have x minus 6 squared plus y minus negative 3 squared equals whatever our radius is squared. Of course, we can simplify that down into x minus 6 squared plus y plus 3 squared equals r squared. And now if we look at this, we're given the point 6, negative 3 as our center, and in the equation it's negative 6 and positive 3. So the main thing here is whatever point they give you as your center of the circle, it's always going to be opposite values within the equation. So keep that in mind as you guys are creating these equations. So if I have the equation, I want to write the equation and graph a circle with a center at 3, negative 2 and a radius of 6. So we're going to go ahead and plug that into our equation of a circle, x minus h squared plus y minus k squared equals r squared, where r is our radius of 6 and h comma k is the center of the circle. Plugging in our values, we'll get x minus 3 squared plus y minus negative 2 squared equals 6 squared. And then, of course, we can simplify this down. Double negatives will turn to a positive, and 6 squared is equal to 36. So for the final answer for the equation of the circle, we have x minus 3 squared plus y plus 2 squared equals 36. If I want to graph this equation, the first thing I'm going to do is I'm going to graph my center point. And that center point is the point 3, negative 2. So I go right 3 on my x-axis, down 2 on my y-axis, and I graph the point. Now from that point, I'm going to go ahead and graph 4 points for the radii. So I know that the radius is 6, so I'm going to go 6 units away from the center in 4 directions. To the right, down below it, to the left, and above it. And again, we're going in 6 units in each direction. Once I have those 4 points that are all equidistant from the center of our circle, I can go ahead and connect those points, creating a circle. So we'd have our final circle as shown. All right, next up, graph x minus 1 squared plus y plus 4 squared equals 9. Determine the radius, the center, the diameter, the circumference, and the area of the circle. So let's go ahead and start by determining each of these items. We're going to start with radius. If I want to solve for the radius of this circle, I must remember that r squared will be equal to 9. The radius squared is always equal to the constant by itself. And again, we can see that within our equation where r squared is in the same location as 9 is. So I can say r squared equals 9. Now if I solve for r, we get r equals positive 3. So the radius is 3 units. As for the center will be the point 1, comma, negative 4. Don't forget the signs will change, so it will be the point 1, negative 4. The diameter, a diameter of a circle is always double the radius. So if my radius is 3, the diameter is twice that. So the diameter would be 6 units instead. As for the circumference of my circle, well, the circumference is the distance around the circle, and it can be found with the equation circumference is equal to 2 times pi times r. Since the radius is 3, the circumference will be 2 times 3, which is 6 times pi, or 6 pi units. And then our area. The equation for the area of a circle will be area is equal to pi r squared. Our radius is 3, so it'll be equal to pi times 3 squared, giving us 9 pi units squared. And again, units will be squared here because it's dealing with an area, and anytime that we're dealing with a two-dimensional shape, It'll always be raised to the second power. Lastly, we just need to graph our circle. So the first thing I do to graph this is I graph our center point, which is the point 1, -4. So I graph the point 1, -4 on our graph, and then I'm going to go 3 units away from that center point in all directions, because the radius is 3 units. So I go to the right, below, to the left, and above. And once I have all 4 of those points, 3 units from the center, I go ahead and I create a circle going through all 4 of those points. All right, next up, write the equation of the circle. So first off, we have this circle here, and we should always ask ourselves, is anything given to us? And the answer is yes. We're given the center of the circle at 4, 5. So that's our center. Now, we need to find the radius of the circle. So typically, it's a little bit more difficult than it is on this problem to solve for the radius. For this one, we can use the method of just counting because it falls perfectly on the grid. If I'm going from 4, 5 to 8, 5, that would be 4 units in length. So again, my center is h, k, and my radius is 4. Now, let's say that we had a point somewhere else on this circle. Let's say that was like right here. And I needed to find the distance from the center to this point. What could I do? Well, if that was the case, then I would use the distance formula. Again, the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And I can use this equation to find the distance between any 2 points. So if I have the center and I have a point that's not perfectly on the grid where I can't count nicely, I can use the distance formula to determine the length of the radius. But since we already know the radius is 4, and we have the point 4, 5 as h and k, I can just plug in and we'd be left with x minus 4 squared plus y minus 5 squared equals 16. And that would be the equation of this circle. All right, now let's go ahead and go to a little bit more advanced concepts, and that's going to be dealing with circles that are written in standard form. So typically, circles will be written in standard form as ax squared plus bx plus cy squared plus dy equals e. And as we can see, we have 2 different variables here. We have x's and we have y's. Now, a, b, c, d, and e, those will all be integers, so those are all numbers here. We will need to complete the square in order to put it into our preferred form. Now, in order to complete the square here, what we're going to do is we're going to group up our x's and we'll group up our y's. And we'll complete the square for each group. Then once we complete the square for each group, we bring them back together and we have the equation of a circle. So again, if I group them together, that would give us an equation for the x's, and it'll be very similar to what we covered in 8.10. We do the same thing with the y variables. So we want our equations to be written in the form x plus 4 squared. This is a perfect square binomial. And the reason that we want it like this is because this is part of the equation of a circle. That's the part that is x minus h squared. You can see that right here. This is x minus h squared. So that's the end goal that we want to get to, because if we can, then we're good to go in the form of a circle. We'd have it written so that we have the center point of our circle and the radius. So in order to do that, we had an equation on Monday that we used. And that equation was to take half of our b value and square it. So in this case, all of the b values will be the numbers in front of just the x variable or the number in front of just the y variable. So big B and big D. Those are our b values that we're finding. So in the case of x squared plus 6x plus blank, if I want to find our new c value, I'm going to take half of 6, which is 3, and square it. 3 squared will give me 9. And with that 9, I plug it in for our new c value. Let's try our next one. Half of negative 12 is negative 6. Negative 6 squared is positive 36. Half of negative 20 is negative 10. Negative 10 squared is positive 100. And then lastly, half of 5 is 2.5. 2.5 squared is 6.25. So this not only allows us to find our new c value, which we'll need to add to both sides of our equation, but it also helps us in completing the square, because when we take half of our b value, that number is the number that will go into our double bubble. So keep an eye on half of your b value whenever you're doing these problems, because it will show up every single time. And it's also a shortcut to save you some time as you're working through these. So let's go ahead and try out some of these problems. Now we're just going to practice with completing the square like we did in Algebra 1 first, and then we'll move on to actually doing equations of circles. So how do you find the missing value, that new c value? Again, to find the new c value, you take half of your b value and you square it. Or in other words, you can use the equation c is equal to b over 2 raised to the second power. Let's go ahead and use this equation in order to solve for x by completing the square. So the first thing that we need to do, if I'm going to solve for x here, if I'm going to complete the square, is I want to make sure that I just have x variables on one side of my equation, which we do here. If I have x variables only on one side of my equation, then I can start off by finding our new c value using our equation b over 2 squared. In this case, our b value is -6. Half of -6 is -3. -3 squared is +9. With that +9, I'm going to add it to both sides of my equation, because what I do to one side, I must do to the other. That leaves me with x squared minus 6x plus 9 equals 25. Now at this point, we're going to go ahead and factor this perfect square trinomial. So we're going to find numbers that add to be -6 and multiply to be +9. But we do have our shortcut as well, this -3 over here. Again, whenever we take half of our b value when we're completing the square, that's the number that will go inside our double bubble. So therefore, if I factor this, we'll be left with x minus 3 times x minus 3 equals 25. And again, we can make this connection here. We see that's -3 and -3. Again, that was half of our b value. So you can just skip this step here of factoring and take half that b value only when you're completing the square. Since these are the same exact binomial, I'm going to go ahead and combine them together, which will give me x minus 3 squared equals 25. From here, I need to get rid of the square, so I take the square root of both sides of our equation. That will leave me with x minus 3 equals plus or minus 5. That will allow me to set up two different equations. X minus 3 equals +5, and x minus 3 equals -5. If I add 3 to both sides of my equation, that will leave me with x equals +8 and x equals -2. And those are our final answers for the value of x. Trying out our second example, x squared plus 4x plus 1 equals 0. To begin, I want only x's on one side of my equation, so I must subtract 1 from both sides. That will leave me with x squared plus 4x plus blank equals -1. Try and leave a little space here for yourself to plug in your new your new c value. To find my new c value, I take half of b and I square it. Half of +4 is +2. +2 squared is 4, so I add 4 to both sides. That leaves me with x squared plus 4x plus 4 equals 3. And don't forget, we can find our shortcut here. From here, I factor this perfect square trinomial on the left side of our equation. So I need to find numbers that add to be 4 and multiply to be 4. And of course, that shortcut tells us that it's going to be +2 and +2. So we're left with x plus 2 times x plus 2 equals 3. Combining our two binomials to create a binomial squared, we're left with x plus 2 squared equals 3. From here, I need to get rid of the square, so I take the square root of both sides, leaving us with x plus 2 equals plus or minus the square root of 3. That sets up our two equations of x plus 2 equals radical 3 and x plus 2 equals negative radical 3. To solve for x, I just subtract 2 from both sides, leaving us with our final answers as x is equal to -2 plus radical 3 and x is equal to -2 minus radical 3. And those are our two values of x. All right, let's go ahead and try it with a circle. So they ask, is x squared minus 4x plus y squared plus 6y equals 48 the equation of a circle? Find the radius in the center by completing the square. So to get started, I'm going to go ahead and split up my x variables and my y variables and leave a space after each. So I have x squared minus 4x with a blank spot plus y squared plus 6y with a blank spot equals 48. I need to find our new c value for each variable. So starting with the x variables, if I take half of negative 4 and square it, I'm left with positive 4. So I'd have to add positive 4 to both sides. If I take half of 6, which gives me 3, and I square it, that gives me 9. So I can plug in a 9 right here, and I'll have to add it to both sides. So we're left with x squared minus 4x plus 4 plus y squared plus 6y plus 9 equals 61. At this point, we can go ahead and we can factor the x variables and then the y variables. And again, you can use your shortcut if you want. You have the negative 2, that was half of our b value. We have the positive 3, that was half of our b value for y. So factoring x squared minus 4x plus 4, I'll be left with x minus 2 times x minus 2. Again, that shortcut allows us to see that. And then for y's, if I factor y's, I'll be left with y plus 3 times y plus 3. And of course, it's still equal to 61. That hasn't changed. Combining my binomials squared, x minus 2 squared plus y plus 3 squared equals 61. That is the equation of our circle. So yes, this is a circle. If I want to find the center, be careful of your signs. The center of this circle would be the point positive 2, negative 3. Again, it's always going to be the opposite signs of what's in our equation. Positive 2, negative 3. Lastly, for our radius, well, our radius squared is equal to 61. So therefore, if I solve for r and take the square root of both sides, I'll be left with r, our radius, is equal to the square root of 61. Those are our answers. All right, our final one. Find the radius and center of the circle. X squared plus 8x plus y squared plus 18y equals 128. Go ahead, try this one out on your own. I'll be posting the answers shortly. Pause the video whenever you're done. Go ahead and hit play again, and it'll be posted. All right, so here's the answer. Again, we start by separating our x values and y values, and that way we can find our new c values by taking half of b and squaring it. For the x equation, I'll be left with 16 for our new c value, and for our y equation, I'll be left with 81 as our new c value. I must also add the 16 and the 81 to the other side of our equation as well, which gives us 225. Factoring our x equation, our blue equation, numbers that add to be 8 and multiply to be 16, well, that would just be 4 and 4. And again, we have our shortcut here. Let me go ahead and circle our shortcut in. So here's my shortcut of half of b, and here's my other shortcut of half of b. So I'd be left with x plus 4 times x plus 4. And then for my y's, I'll be left with y plus 9 times y plus 9. And of course, it's still equal to 225. Combining the binomials that are the same, I'll be left with x plus 4 squared plus y plus 9 squared equals 225. Lastly, I just need to list the center of our circle and the radius. So when we list the center, be careful of your signs. The center will be negative 4, negative 9. And the radius squared is equal to 225. If I take the square root of both sides to solve for the radius, we get radius is equal to 15. All right, guys, thank you so much for watching today. If you have any questions, please feel free to contact me. Other than that, have a great rest of your day.